Welcome to the Biophotonics course. We will continue our studies, and today we are going to start the new module in which I am going to discuss lasers for biophotonic applications. Let's get on with it. So, if you are someone like me, you will consider laser to be one of the most significant human discoveries of the past century. There are several seminal discoveries that humankind have made, and that have resulted in a quantum jump in the human civilization. The discovery of the fire, the discovery of agriculture, the discovery of wheels. Lasers are one such discovery that has helped human being take a quantum leap, take a jump per se, in advancing its civilization. So, to rectify my previous statement in which I said that perhaps lasers are one of the most seminal discoveries of the last century, I would go one step further and I would say lasers are perhaps one of the most seminal discoveries of humankind during its entire time in this planet. Laser is all over us. It's all around us. We use it on a daily basis. Obviously, in biophotonic applications, you have laser eye surgery. Everybody of you have heard, or you must have been to discotheques. I know some of you most definitely have, or you have seen laser shows. There are laser welding that we see in manufacturing processes, and ubiquitously we see it in laser pointers. Nowadays, if you have been to any presentation whatsoever, you have seen it in laser pointers. So, hardly there is any aspect of life that have not been invaded by laser. From military applications, laser based guns, laser aircraft, laser carriers, laser is everywhere, and especially this one. If for those of you who know what this is, you are awesome, and you know that the force is going to be with you always. So, let's see how this thing came about. What is laser, and how did this simply a new source of light became this popular, this ubiquitous, this useful, and this prevalent all over the planet, and have helped us take a quantum leap, take a quantum jump in technology. So, some history lessons. Well, you obviously know who Albert Einstein was. This was the gentleman who first postulated about stimulated emission. I will come to a moment what stimulated emission is, but those of you who are from physics or related background will know what laser stands for: light amplification by stimulated emission of radiation. So, what is stimulated emission? It is some kind of a different type of emission other than spontaneous emission. We have discussed spontaneous emission in fluorescence. So, stimulated emission is a new type of emission which is completely opposite to that of absorption. In absorption, the electron, say for example electron at this present moment, though other examples are there which I will give. In absorption, an electron absorbs, eats a photon and goes to the upper level. Electron eats a photon and goes from the lower level to the upper level. Stimulated emission could be considered as vomiting. I know, bad analogy, but still bear with me. Stimulated emission could be considered as vomiting, in which whatever it has eaten, whatever frequency, phase, or the property of the photon which it has eaten, it will return it back, it will vomit it back, it will emit it back upon activation by another photon of the exact same kind. Everything will be clear, just bear with me. This new phenomenon that there is a second type of emission, or as they said, or as Rudolf Ladenburg, who was one of the first German scientists, first Jewish German scientist who emigrated to America during the 1930s due to the prevalent political situation back home in Germany. He coined the term negative absorption. Negative absorption. Absorption is where light is eaten, light is consumed. Negative absorption is where the exact same light, exact same type of light, exact same photon is emitted, or I used to say vomited, right. So, these two gentlemen were seminal in developing the overall theory that there can be a second type of emission, not just fluorescence. Remember, we discussed fluorescence previously was actually discovered by Sir Stokes, and later Professor Jablonski described it properly and what spontaneous emission is doing. These two gentlemen came up with this idea that there could be another type of emission as well, which is stimulated emission, which is equivalent to absorption but opposite in effect. Hence they call it negative absorption. Hence they call it negative absorption. Exact absorption but in the opposite way. Exact in the opposite way. Spontaneous emission is, on the other hand, there is a mismatch. Whatever is eaten is usually not vomited, something else. Here it's the same thing. Whatever goes up comes down upon your intervention, upon being activated by something else. So it is a controlled process, or it is something that is a interventory process. It's not just spontaneous, or it's not just natural. So several people were working on similar things since the 1930s and 1940s. The theory was developed by Einstein and Landenberg. Later people started working on masers. Can we have microwave amplification using stimulated emission of radiation? And they were able to solve some of the maser problem. Both American scientists were working on it, as well as Soviet scientists were developing it independently. Maser was actually demonstrated. It worked for a very small period of time. It stuttered, and more or less it went along its way. During the 1950s, there was this PhD student, a graduate student called Gordon Gould. He was a New Yorker, and he was doing his PhD in Columbia University in New York. During his time, during his PhD-ship, during his graduate studies, Bell Laboratories, Toens and all, were working on thinking of if maser's property can be taken into optical domain, mid-infrared, or even visible range, because that would be cool and they will find several different applications. And they were working on some kind of a maser-like property in visible or infrared, and they were debating which one is better, which one is nice, which one is feasible. When this gentleman, this Gordon Gould, around 30 something PhD student who was working on his PhD thesis on thallium, this radioactive material thallium, came up with the idea that maybe, just maybe, we have the technique, we have the operational feasibility, we have the design of something which he coined as laser, light amplification by stimulated emission of radiation. He used the azer part as a suffix, and he used it for several different terms, radio azer, razor, or microwave azer, maser, or azer all stands for amplification by stimulated emission of radiation, UV-azer, IR-azer, but laser is the one which stuck. So this guy, while talking with Bell Laboratories Toens, came up with this idea, or he already had this idea, and he wrote this in this notebook. And this is an interesting story. He wrote this in this notebook. You will see the design, and he thought that this might be something important. So he went to the nearest candy store that sells candies, and that had as a part-time business a notary shop. You know, notary which affixes stamps, write it in stamp paper. So obviously you might have seen these, neighborhood corner shop that usually sells this, sells you products, sells you sweets, but at the back corner there is also a photocopy shop, a mobile phone repair shop, a telephone shop, a notary shop. So he went to the nearest, his favorite candy shop, I assume it is his favorite, and got this notarized. But by the time actually he left his PhD studies thinking that he needs to prove to get it patented. Notarization is not patenting, but he started working on making a laser. But by the time, with huge amount of time, money and energy, Bell Laboratories have already beaten him in producing some of the simplest demonstration of lasers, and he went into a huge court case with Bell Laboratories and others that I was the first, and there was huge amount of controversy. He has to wait 30 years for his due to be credited. But while these two people were fighting, Hughes Laboratories Theodore Maiman in 1960 actually utilized ruby as in the popular semi-precious stone, and actually demonstrated the laser or lasing effect. In the meanwhile, there were Soviet physicists Alexander Prokhorov as such who did seminal work. So there is no one such discoverer of laser. Who invented laser? You probably do not see this question coming up, because there was not one single person who discovered laser. It was an effect of all human beings coming together, maybe not always together, sometimes acrimoniously, but it is the overall fruit of human genius from all over the place, Germany, New York, Moscow, etc., all coming together to develop what we call is a laser, and how it has changed the world. I like to have a reading of the lives and times of these scientists, because usually we identify scientists with a particular formula or a particular concept. But remember, scientists are also human beings. They are living, breathing human beings. They had setbacks, they had failures, they had triumphs, they have their own personal problems, they fought in war, they loved music, and talking or learning about them humanizes for me the overall concept they have developed. A human being is much more complicated than simply E equal to mc square or a concept. That person was once a human being like me and had to go through similar trials and tribulations, and how that person have struggled to meet those achievements, and despite all his general faults, he came up with something this profound, is actually inspiring. Some people like it, some people don't. So if you dislike it, just let me know. I will keep the history lessons little less. So let's understand how laser or what stimulated emission actually is. So we know what happens in absorption. This has been discussed. So you have say for the time being electron at a lower energy level. Upon absorption of a photon, when a photon is hitting it, when a photon is exciting it, it goes to the upper level. It goes to the upper level and the photon disappears. It has consumed the photon has taken the electron from the lower level to the upper level, provided of course the photon has sufficient amount of energy. The photon has sufficient amount of energy to at least, remember for your fluorescence lecture, at least breach this gap. Okay, it cannot be somewhere in between or less. It has to have sufficient energy. We are assuming that the energy of the photon is equal to the band gap, life would be easier. So the photon which has affected or which has interacted with it, the electron consumed it and moved to the upper level. Now when the electron has consumed the photon, has moved to the upper level, by nature after some time randomly it will come back to the original place and emit the photon that it had consumed. Or if it is not fluorescence, if it is fluorescence with a different frequency of photon, if it is just elastic, then it will emit the same amount of photon. Spontaneous emission, two things you need to be clear. This is spontaneous. This happens automatically without any intervention. So, the electron goes up, the upper level is unstable. After some time, randomly it returns back. It can be at any specific time, any random occurrence of time, the electron will return back and will emit a photon. So, this is rather a spontaneous and hence by definition more or less a random emission. We can somehow understand that what will be the energy of the photon, and we can also may ascertain that it will be within a nanosecond time, 10 nanosecond time it will be emitted, but we cannot pinpoint, we cannot exactly say, because it is a random event. If there are thousands of energy levels and thousands of electrons have gone out, all of them might come down within a nanosecond time, but they will be of different characteristics. Their occurrence within that nanosecond will be at different intervals. So, all I am saying that this is randomly emitted. It will go up, upon its volition it will come back and it will emit a photon. Okay. And we can have some amount of prediction, but overall it is uncertain. It is a random event. It will come back, and if you have 10 different electrons, 5 different energy levels, etc., the photons that is coming out are of different frequency, different phase, different energy as such. Stimulated emission. Now, let us talk about stimulated emission. Stimulated emission happens when there is already existing an electron in the higher energy level. Please pay attention, this is crucial, this you need to know, even physics student, that there is an electron already existing in a higher energy level and it has not emitted anything yet, meaning it has not done any spontaneous emission and it has not returned back to its original ground state or low energy level. It is still in the upper level. While it is in the upper level, whilst it is in the upper level, you are intervening from outside. With a photon of the exact same energy as that of the band gap, as that of the energy gap, right? You are intervening, you are externally supplying, you are taking a photon from outside. You have figured out what is the gap, what is the energy gap, you have synthesized a photon of that particular energy and you are throwing that photon to itself while it is up, while it is still up. Remember, if it happens in absorption, when the electron has come back down and you are supplying some energy, it will consume and it will go up. So, here it needs to be understood that the electron is already up. While it is up, you are sending a photon of the same energy that it has previously consumed. So, there is no difference in the energy of the photon that it has consumed and gone up. So, when it is already up, it is already full, it has eaten till its heart's content, it is full up till this, you are adding more food into its mouth. What will happen? It will come down and it will throw up, it will vomit whatever it has already eaten. I know very bad examples or very bad analogies, but consider yourself this example. You have eaten full, as much as you can, the fullest capacity you have eaten, and now I have taken the same quantity of food that you have eaten and now I am trying to shove it down your throat. What will happen? Not only you will not eat the next set of food, you will vomit whatever you have consumed. As a result, when you have put one photon, two photons comes out. One photon from the original, which is unconsumed, that is the food, the next set of food that you could not consume, and the food that you have previously consumed, that is vomited. I know, no one has taught you laser actions using these sorts of metaphors and analogy. Yeah, I know, trust me. So, two things needs to be clear here. First, stimulated emission will only happen when the electron is at the higher level. The electron is at higher level. Usually electrons are mostly in the lower level. These levels are higher level, hence unstable. So, you know, if an electron goes to the upper level after some intervention, it always have the tendency to come back. So, we do something called population inversion. All of you know what population inversion is. We try to reverse the process. We try to ensure that the population of the higher level, the population of the electron at higher level is more than the population of electrons at lower level. Only then, when the electrons are at higher level, when more electrons are at higher level, then more prominent laser action will take place. No laser action will take place if the electron is at lower level. If the electron is at ground level, no laser action will take place. Laser action will only take place when all of these electrons are at higher level, or most of them, or a majority of them are at higher level. Hence, we call that inversion in population. Usually, there are more electrons at lower level, less electron in upper level. Here, we have reversed the process, where more electron has gone into the upper level. Some of them have been absorbed, or we have sent some amount of energy. All of them have absorbed, all of them have consumed and gone up. While they are up, we are ourselves, while they are up, while they are still up, while they have not come down, we are supplying extra energy, we are supplying external photon while they are up, and that made the electron throw up. That makes the electron vomit. That makes the electron emit whatever it has consumed before. It will only happen, it will only throw up if you give energy, or if you give a photon of the same kind that it has previously consumed. Now, since I have lots of students from physics MSc and physics doctorate, I have a question. What will happen if this photon is of a different energy? Will you get a stimulated emission? Will you get a stimulated emission if this photon is of a higher energy? You see, this is not part of our biophotonics, but I want to ask a fundamental question. Why do we have stimulated emission? Why do we have stimulated emission? Why does electron throw up? Why doesn't, upon activation by this energy, this photon, it goes further up? It could go further up. Why it is not going? Please, physics student, enlighten us. Please answer this question. I will give you a hint. Obviously, I will give you a hint. This is fascinating, but I got some comments that the physics part is quite less. So, I am asking your help to add some amount of physics part here. The idea here I would like to make is, say, the energy of this electron at the upper level is this difference. Yes, energy of this electron is this gap. The energy of the photon is exactly same. So, can I say somewhat that the energy level of photon and electron are same? If the energy levels are same, if the energy of this coming photon when the electron is at upper level is exactly same, can there be an energy change? Can there be an energy difference? Think of it like this. There are two bodies, both are at the exact same temperature, 23 degrees Celsius, 23 degrees Celsius. You add them together. Will there be an energy difference, or will there be an energy flow? Or electronics engineer students, you know current flow when there is a potential difference. When there is no potential difference, when there is zero voltage, what will be the current? When there is zero voltage, what will be the current? Someone of you may say zero current then. Okay. So, if there is no energy change, if the electron has already consumed this and this energy is only sufficient to take it from here to here and it is already here, then what can it change? What can it interact? The energy will not be changed, the energy is same. Can the momentum change? Can the spin change? Momentum and spins are these fundamental quantities. Momentum determines direction. Momentum determines direction. The life science students or biotechnology students need not go into this deep to intervene what stimulated emission is, but I am asking a question to those of you who are interested to think about or to understand or try to see what stimulated emission or why stimulated emission is. 100% or almost majority of books actually tell you what stimulated emission is. My question is why? Why does it happen? Why doesn't it go further up? Why does it have to come down? Why doesn't it go to somewhere else? For the time being, I will keep it as open question for you to search. I'm not Google. I'm not going to give you every single answer. In the live session, maybe we will have a debate, we will have a discussion regarding this. But for the time being, understand that when you give the same amount of energy that it has already consumed, the emphasis is on the term same amount of energy has been given, it will come down vomiting what it had already consumed. And therefore, you have the original which you have intervened, which you have externally supplied, and the electron is going to give you something else. The electron is going to give you the same thing that it has consumed before. So, you started with 1 photon, you now get 2 photon. In other words, you have amplification. You have 1 photon converted into 2 photon, and this so on and so forth. 2 becomes 4, 4 becomes 8, 8 becomes 16. You have amplification as this photon propagates by stimulated emission of radiation. Okay, and this is basically stimulated emission of radiation. Here 2 things needs to be absolutely cleared. First and foremost, as I said, we are assuming it's electronic states or electrons going up and down. Not necessarily. For laser action to happen, you can have it with simply molecules going from lower vibrational state to upper vibrational state. Remember your spectroscopy course, lower energy level to higher energy level, lower vibrational level to higher vibrational level. Carbon dioxide laser is a prime example which does not use electrons movement up and down to generate photons. It generates vibration levels of molecules, of CO2 molecules to generate laser. Secondly, the lower level does not necessarily has to be ground state. The lower level does not necessarily has to be the lowest state of the molecule, lowest state of the atom. It can be anything below the higher state. So, remember we said S0, S1, S2, S3 in fluorescence. In fluorescence we discussed all of that levels. The stimulated emission can happen between S2 and S3. The stimulated emission can happen between S5 and S6. Upper and lower, it does not necessarily needs to be between S0, S0 and S1, S2 or S3 or S4. It has to be between any 2 upper level and lower level. As long as they are upper and lower, stimulated emission can take place, provided you have supplied energy matching the energy gap or matching the band gap between these 2 bands, between these 2 energy states. It does not necessarily has to be from ground state, from the lowest energy states itself. It can be any state in between. That is stimulated action. So, pay attention what actually happens in laser, how exactly laser operates. So, in a laser to operate, though it is stimulated emission, you will see that all 3, absorption, spontaneous emission and stimulated emission, all 3 needs to be operated one after another in a actual laser to work. So, in lasing operation you need 3 things basically. You need an active material, a material which basically will lase, a material which has either electrons or molecules which will go from lower level to higher level, any lower level to any higher level, and you will have a pump which is a source of energy. That is the one which will give you external photon, that is the one which will energize, not necessarily external photon, but it is a source of energy. You will see why. That will energize the electrons in the active material or molecules in the active material to go from lower level to higher level. This is the source of energy that this will intervene, that this will consume and go up. And you will require 2 sets of mirrors. You will require 2 sets of mirrors, and this thing, this 2 mirror in between which you have put the entire active material and the pump is considered as an optical cavity. This optical cavity has a very, very important function. I will come to all of them, each one of them one at a time. So, this is the active material, this is the pump source, and this is the mirror. R stands for reflectivity. I will be describing you what this is in a moment. So, let us start with the operation of a laser. You have an active material, it has, say, assuming electrons. Most semiconductor lasers are electron based, and that is the most common one. So, you will utilize it. So, you have an active material which has large number of electrons, supposedly at a lower energy state, maybe ground state. You pump some amount of energy. This energy can be an electric current, that can be a chemical reaction, it can be optically pumped, it can be light from another laser. So, this is some sort of a laser that will activate, that will energize, or that energy will be absorbed by these electrons in the active material, and they will move to the upper level. They will move into the upper level. After some time, when this has been switched off, the pump has been switched off, say, they will return back to their original ground state by emitting different amounts of photons, in spontaneous emission. In spontaneous emission, they come back and they after some time return back to this original position. This will come back to its original position. That animation I was unable to make. This actually will return to the original ground level position, and the color represent different types of photons that it will emit. Yeah, different photons at different times, because different electrons moved at different time at different level, and they returned back and randomly emitted different types of photons. Now, these two mirrors, they act as optical cavity or optical resonator, or in a sense optical filter, that will filter or that will allow only one type of photon to survive inside the cavity, inside their chosen area. These are the two mirrors. Due to constructive and destructive interference, we will talk about a little bit about optical resonators at end. These are optical resonators, optical mirror, optical cavity. They act as a filter. They will allow only one type, only one frequency, only one energy of photon to survive inside the entire cavity. So, of the different randomly generated photon, only one is picked up, rest of them are attenuated, rest of them are killed off. Only one of them of the photon, only one type of photon that the active material is emitting due to spontaneous emission is kept, rest of them are killed off by this Fabry-Perot cavity, by this optical resonator, by this cavity. These photons are allowed to survive into the system. These photons of all these different type of photons are allowed to survive inside the cavity, inside the system, inside the two mirrors. Well, these are mirrors. So, what do you think when photon or when light hits upon them? They will be bounced back into the system. They will be bounced back into the system. So, are you getting where I am getting at? So, this is the exact photon that has now gone into the system to now generate stimulated emission. So, those electrons which are in the upper level and whose energy difference matches that of this photon will now be interfered by them. When this will interfere with those photons that has consumed the exact same photon earlier and still has not come back, because spontaneous emission is random, it may or may not come back. Those of them which may not have come back, or you can switch on the source of energy once again for it to go up, but that is besides the point. All those electrons which has consumed this specific, with an underline under the term specific photon, and has gone up, will now be interfered only by this type of photons, and stimulated emission will happen, which will generate more of the same kind of photon, which will again hit the mirror and return back into the active material, and this process will built in and built in. And here the beauty is only one type of photon, the rest of the types of photons are killed by these two mirror. The other photons are killed off by these two mirror. These two mirror is acting as a filter, as a resonator by constructive and destructive interference. It is allowing only one type, one frequency, one energy of the photon to survive, which is the yellow one. And it will only interact upon those molecules, those atoms, those electrons that has consumed the same thing. That has consumed the same thing and still up. It is intervening it, that electron throws up, generates one of the same thing, the matching photon, that again goes out, hits the mirror, returns back, and you have an amplification building up, building up, building up. What do we do next? These sides of two mirrors, one is perfect, whatever falls on it gets reflected back, since reflectivity is 100%. This one, the reflectivity is little less, meaning this is not a 100% perfect mirror. So, whatever light or whatever photon falls into it, a tiny percentage can go out. This tiny percentage that can actually go out, that prevents the system from overloading, is your laser. You can rewind it several times to see what I just said. All three actions take place: absorption, spontaneous emission, and stimulated emission. You absorb, the material goes up, the molecules, the electrons goes up. After some time, it tries to come down by spontaneously emitting photon. Several photons come out of it at a random interval. These random interval photons, some of them are killed off, only one type is selected, that is bounced back into the system. That bounced back photon contributes to the stimulated emission, that act upon those electrons who are still up, who have consumed the exact same photon, and it generates two photon out of it, or it amplifies the photon. This thing goes on and on and on, while energy or the photon starts building up into the system, and through an imperfect mirror, a small stream of light, a small stream of photons are taken out, and since stimulated emission has the exact same type, so all the photons that are coming out in laser have the same momentum, have the same energy, have the same phase, everything remains as it is. Yes, that is simply how laser works. Okay. So, what are the function? The pump is an energy provider. It can be a current, a discharge, flash, chemical reaction, other laser. The active material, more or less we have utilized everything as an active material. Even single atoms have been shown to laze, as long as you have two levels. Only thing we find difficulty is metals. Why do you think metals do not provide lasing action? I am not going to give you every single answer. Resonator is the one which select the properties, simple two mirror Q, or so many people will ask me what optical resonator is. Just go through any normal physics textbook. I will tell you that resonator is the one, depending on the length, based on the formula, depending on the length is determine the frequency it allows. So, this is given by this formula, where n is the refractive index of the material in between these two, c is the speed of light, L is obviously the length. So, L is obviously the length, m is the number of mode 1, 2, 3, 4, n is the refractive index. So, it depends on this particular formula. In air, if this is air, you have put two Fabry-Perot cavity in an air, then this becomes 1. So, L by 2, meaning only those lambda, only those wave that can make a full circle or that matches, the lambda needs to match with the length. So, by changing the length of the mirror, you can change the lambda. If you can change the lambda, you can, or you can select the lambda that can survive. only that wave can survive inside these two mirror, which has a full round circle. When it comes back to the original position, it has gone through the exact 360-degree phase shift. It has come back to the original position. Any other lambda will no longer be accepted. M is mode 0, 1, 2, 3, 4, and N is refractive index. If N is 1, then this becomes, or M is 1 and N is 1, this become lambda by 2. So L stands for lambda by 2. Very easy. Any normal physics textbook will do that. The lambda, only those wave will survive whose energy falls, which allows it for constructively interfere with one another, right? A specific type of photon. So basically you can select which photon to you want to accept by changing the length of this resonator, because length of the resonator will determine the lambda will determine the frequency will determine the energy, and what particular energy, that energy needs to match with the upper level energy and lower level energy of a specific material. So this is it. Optical resonator is simply there to ensure there is a proper full cycle or constructive interference of the wave that goes through. Yes, I know I toggle between wave and particle nature of light, and everybody does that because you know the bad reasons. So let's summarize. The pump mechanism provides energy for absorption. The spontaneous emission produces photons in all direction in the active material. The resonator mirror attenuates some photon and reflects selective photons back into the active material. The reflected photons cause stimulated emission inside the active material, and the selective photons are cloned or amplified. Biological students will chuckle at why I use this term cloned, and part of the overall building process chain reaction is transmitted out by an imperfect mirror, and that light is your laser. That's it. That's the end of story. Wait. What happened to all the rims of mathematics you guys used to do? Come on. What happens to the tons of mathematics all of you used to do to understand what laser is? What happened to them? This is my revenge. I am challenging you as well as me to see if you can understand the basic concepts of physics, however difficult it might be, those concepts which has been monopolized by physics, quantum mechanics, laser, this, that, without touching mathematics. Can you understand? Can you understand the concept? Now, think about the laser pointer you have. What do you think is the pump here? I would say it's the battery. And it has a small crystal, a gallium arsenide crystal, which is the active material. Your energy from the battery is absorbed by the crystal. It has population inversion, and that crystal is put in two small mirrors or inside a cavity, an optical resonator, and the same process which you have now understood results in stimulated emission. Look at your laser pointer and you can tell me what you understand. See, physics is poetry, mathematics is the grammar. When you are looking at the poetry, when you are reading a poetry, is the rhythm, it's the words that are connected together that matters. That's the spirit of poetry. Everyone understands that without grammar nothing will be there. But the spirit, the essence of a poetry is in its rhythm, not on the grammatical concepts that makes all those words coming through. And you know who said that? Richard Feynman. I know by this time I have lost half of my physics audience, half of my physics student, because this is blasphemous, and prior to that I have lost half of my biology student because I used electronic truth table to describe how data is coded in DNA. And yes, I know my fate is waiting in seventh hell, or as the cool kids say, Habia Dozak, once I die, because of this blasphemy to both physics and biology, and I await my fate. Absolutely no problem. But understand this, the concept has to be clear. Mathematics will help you polish the concept, but the concept needs to be clear. I have seen several of the students who have gone through tons of mathematics, yet they still do not understand the basic concept of laser. Laser is simply this: you have an absorptive material which absorbs, goes up, it emits different type of photons randomly. Of those random photons it has emitted, one is selected, it is returned back into the system, that energizes other elements, it energizes other electrons. Some of the electrons which are down can absorb and go back, and the next photon it is hitting will allow it to vomit, and so on and so forth. So the same type of photon can only survive into the system. It is building up, and one of it is removed. One or couple of them are transmitted. The transmitted one forms laser. Please be my guest and go through all those mathematical calculations to understand how beautifully this and that happen. But I will stick to this one because I am teaching to an interdisciplinary group. I understand that some of you might be terribly upset and this is not the way, but well, let's deal with it anyways. So these are the concepts that I have covered: stimulated emission, optical resonator, laser components and laser operation. And please, if you want to deal more on the laser part, especially the basic, go through the Photonics by Ralph Menzel and optical properties of solids. I shall continue with my topic in next day. Thank you very much.